In October 2022, Google's quantum chip called Willow managed to solve a mathematical problem that would have taken the world's most advanced supercomputers over 10 septillion years to crack. It took Google's quantum computer only 5 minutes. This breakthrough serves as a stark reminder of the tremendous processing power quantum computers possess and how quickly they're re-evolving, and it signals that the cybersecurity industry must act fast if it is going to stay ahead of the curve. If you're working in fields such as government, finance, or telecommunications where secure data transmission is paramount, well, it's because the technology has finally reached a tipping point where its capabilities cannot be ignored, and ECC rely on the difficulty of solving mathematical problems in polynomial time on a classical computer. However, as mentioned earlier, specialized algorithms such as Schur's algorithm can efficiently solve these same problems on a quantum computer. Once large-scale fault-tolerant quantum computers become a reality, which experts predict could happen sooner than later, the security landscape will shift dramatically. The PQC is not a distant future technology. Similarly, the United States Cybersecurity and Infrastructure Security Agency, CISA, has recognized the urgency of the situation. The cost of a data breach can be measured in millions of dollars, not to mention the irreparable harm to reputation and trust, and issued a draft guidance recommending that federal agencies begin piloting PQC implementations. Organizations should not wait until quantum computers pose an imminent threat to their operations before taking action. Early adoption of PQC allows organizations to get ahead of the curve and implement robust quantum-resistant solutions before their competitors. This is due to the highly sensitive nature of the data that these organizations handle, including customer financial information and proprietary trading algorithms. Telecom providers manage vast amounts of customer data, and ensuring the confidentiality and integrity of this data is crucial. To ensure your organization's readiness for the quantum era, consider the following steps. Engage with industry peers and cybersecurity experts to share knowledge and best practices, and explore partnerships or collaborations that can accelerate your organization's PQC adoption. Remember, the quantum revolution is not just a technological advancement, it's a paradigm shift. Embracing PQC early is not just an option, it's a necessity. By taking proactive steps today, you can ensure your organization's resilience and thrive in the exciting world of tomorrow. Don't wait for the disruption to reach you. Shape your future today. Conduct a thorough assessment of your data and systems to identify the most critical assets that require immediate protection. Develop a roadmap for implementing PQC solutions based on your risk assessment. Prioritize the adoption of PQC for systems and data that are most critical to your operations and most at risk from quantum threats. Furthermore, telecom networks are critical infrastructure, and their security is essential for maintaining the functionality of modern society. Any lapse in security could lead to substantial financial losses and reputational damage. Finance and insurance companies are also highly regulated, which drives the need for robust cybersecurity measures. By staying ahead of the curve, companies can avoid any potential disruptions to their operations caused by cybersecurity incidents resulting from quantum attacks. Finally, it enhances reputation and trust, demonstrating a commitment to cybersecurity and proactive risk management. Through PQC adoption can enhance an organization's reputation and build trust with customers and partners, especially in sectors like healthcare and finance, where data privacy and security are paramount. Being seen to be taking the necessary steps to stay ahead of the curve can make all the difference. This proactive approach ensures that businesses can continue to operate securely and confidently in an increasingly digital world. Companies are already adopting it to stay ahead of the curve. Firstly, it helps ensure resilience. By proactively adopting PQC, organizations can strengthen their security posture and reduce their vulnerability to quantum threats. This is crucial for industries like finance and healthcare, where data breaches can have severe consequences. Secondly, early adoption allows for better risk assessment. By testing and implementing PQC solutions in advance, companies can identify and address any potential issues or challenges well before quantum computers pose a significant risk. This helps in developing contingency plans and ensures a smoother transition to post-quantum security. Thirdly, it enables continuous operations. Moreover, evolving regulations such as the European Union's General Data Protection Regulation (GDPR) are pushing organizations to take proactive steps towards data security. GDPR grants individuals the right to have their data protected against various threats, including those posed by quantum computing. Consequently, Companies that fail to safeguard their data adequately may face substantial fines and reputational damage. We've entered the age of quantum disruption, and the window for preparation is rapidly closing. The risk of data breaches and cyber threats becomes significantly amplified. Imagine a scenario where confidential government operations. Fortunately, the cybersecurity industry is already working on the next generation of encryption, known as post-quantum cryptography or PQC. This approach involves developing encryption algorithms that are secure against both classical and quantum computer attacks. NIST has been leading the charge by launching the Post-Quantum Cryptography Standardization Project in 2017. The goal is to select one or more PQC algorithms that will form the basis of new encryption standards. Financial transactions or private communication networks could be intercepted, and attackers could easily decipher the information. The consequences of such vulnerabilities could be catastrophic, but the leap from 128-bit to post-quantum security is a much bigger challenge. It requires not only new encryption algorithms, but also new hardware and software infrastructure. The threats posed by quantum computing are so significant that even organizations currently unaffected need to start planning for a post-quantum world. What exactly is the threat? How do we counter it? Quantum computing harnesses the principles of quantum physics to perform calculations in ways that are impossible for traditional computers. This means that quantum computers can break through many of the encryption algorithms that we rely on to keep our data safe. For example, Schur's algorithm, an algorithm specifically designed for quantum computers, can efficiently solve the integer factorization problem and the discrete logarithm problem. These are the same problems that many of our current encryption protocols are built upon. And when quantum computers capable of executing Schur's algorithm at scale become available, our current cryptographic methods will be rendered obsolete. And what can you do today to future-proof your organization? How does quantum computing threaten cybersecurity? It's important to understand the quantum threat landscape. Most of the commonly used encryption algorithms, such as RSA for instance, the transition from 32-bit to 128-bit encryption was seamless, thanks to the Advanced Encryption Standard or AES. What's post-quantum cryptography, and why should you care? While there is no single magic bullet for quantum proofing all data, PQC offers a structured approach to address the issue. For instance, the French Data Protection Authority (CNIL) fined Google €100 million for non-compliance with GDPR regulations, underlining the importance of anticipating and mitigating quantum risks. As the threat posed by quantum computing grows, it's crucial to remember that once the damage is done, it's often irreversible. Why early adoption is essential to mitigate the risks associated with quantum computing. There are several compelling reasons to adopt PQC early. Proactive adoption of PQC allows organizations to maintain business continuity in the face of evolving threats. Which industries will lead the way in adopting PQC? According to industry analysis, the finance and insurance sector will be the first to adopt PQC by 2025. Additionally, the telecommunications sector is poised to be an early adopter of PQC. What can you do to prepare for the quantum era? Stay informed about the latest developments in quantum computing and PQC by following industry best practices and guidelines. Thank you for watching this video.